if the side opposite the 30-degree angle, if we call that A, the side adjacent to it will be A times the square root of 3. And the hypotenuse will always be 2A. So if we look here, in this case, A is 4. If A is 4, this is the hypotenuse, and it's across from the 30-degree angle. So my hypotenuse is 2 times 4, which is 8. And we could do the same kind of thing here for x. We would say x is 4 times root 3, which would be 4 root 3. Okay. So again, in a 30, 60, 90 triangle, the side opposite the 30-degree angle, that'll be our base. So let's see if we can do just another type of these here. We'll do another right triangle. We'll do a couple more maybe. Yikes. There we go. This is a right angle and this is the 30-degree angle. And I tell you that this is, maybe I say that this is 18. You can't see it. There we go. If I say that this is 18, what is the side length AB? Good. Yeah, 9. So if we check it again, the side opposite would be like our A. So we could call this A. That means 2A is equal to 18. So A must be 9. What would that make AC? Sure. You were ready on that one, Gruber. Nice job. And we, as an exact value, we would call it 9 times the square root of 3. Okay? And that was really the basis of our 13.3 work. Okay? That was what we were trying to hit home. We also talked about one other type of triangle. And the other type of triangle we talked about was an isosceles right triangle. And if I tell you that's not really isosceles, but let's just say it is. If this is x and this is x, the hypotenuse here is x times the square root of 2. Okay. So if I give you another one, let's do one more example like this. If I told you that these are congruent and this is 4 and this is a right triangle, these are right triangles. If this is 4, what is the side of my hypotenuse? Well, if this is x times the square root of 2. So if this is 4 as an exact value, we would write this as 4 root 2. Okay. And you could figure out the decimal, but if we wanted the exact value, that's what we'd be after. I think that's enough on those. How is the 13.3 HRW going? Is there any questions on the 13.3 HRW? Anything that we should go over? Taylor doesn't think so. If you've got questions, you can always stay on. You can ask them now. You can email me later. But I do think those are important that we're able to do. Otherwise, we're going to be really quick today. Measures. we can solve a triangle by finding all the angle measures and the side lengths, and we can use our trig ratios to do this. Okay, so let's remind ourselves of some of our trig. The sine of an angle, call it sine of an angle. What is the trig ratio associated with sine? Associated with sine. If I had a triangle here, call it a right triangle, and I call this A. Yeah, there you go. Good. Opposite over hypotenuse. This would be my opposite side, adjacent side, and hypotenuse. Okay, good. So when we talk about the sine of an angle, it will be the opposite over hypotenuse. What do we know about the cosine of an angle? Adjacent over hypotenuse. And then we've also got the tangent of an angle. And what is tangent of an angle? Good. Opposite over adjacent. Good. Okay. And we're going to work a little bit today with our inverse trig functions again. So you may need a Desmos calculator open somewhere along the lines. Because remember, if I was going to find the angle measure, we would use like the inverse of sine. So sine inverse. Sine inverse. That'll be one of our keys today. Okay, so let's solve a triangle, and let's just do one of these. I want to solve this triangle. Here we go. Solve the triangle. And it looks like all they're going to give us for this triangle here is that it is a right triangle. We'll call it DEF, so DEF. This is a right triangle, and what they're going to do is they're going to give us a 5 and a 4 here. And that's it, okay? And what we're asked to do is solve the triangle. Well, to solve the triangle, it means I have to have all the angles and all the sides. I've got 2 of the sides. How might I be able to find this third side? Give me a 1 to 5 in the chat box here of how confident you would be to solve one of these on your own. If I asked you to solve a right triangle, could you do it on your own? Just some honest answers here. 3s, 3s, and 4s, lots of 3 to 4s, 3s, 4s. Okay, then let's do one more here just to make sure we've got it. And I'll try and ask more questions along the way. Okay, I'll try and squeeze it in here. See if we get one more of these. Here's a right triangle. This is 7, and this is 24. Let's call it U, B, W. I'm looking for UW. That's the one I want first. What do I use to find that side length? Okay, looks like we're going to get 25 here because if I take 24 squared plus 7 squared and make that equal to this side squared, you can call it UW squared. I'm just going to take the square root of whatever this is. And the square root of, let's see, times 25. That should be 625. There. Which means we do get 25 for our side length. Okay. Now that we've got the 3 side lengths, we can kind of pick and choose which ones we want to use. So let's find the measure of angle U. And let's do that using the sine of U. So what am I going to do to solve for this sine of U? What ratio do I need to set up? Good. Opposite over hypotenuse, which in this case is what? Be a little careful there, Gavin. I don't know if your finger slipped. Y over 25. Okay, so we have opposite. Yeah, there we go. 7 over 25. There you go. 7 opposite over 25, which is our hypotenuse. That's why I always like finding that third side first, because it makes me have all of the numbers here. So we call this our opposite, and this is our hypotenuse. Okay. Well, then to solve for the measure of angle U, which operation do we need to do? Okay, so we found area using this previous method, but now we've got trig functions. And what we can say is that the area of a triangle can be found if we have an angle and the 2 adjacent sides. So we need SAS, side angle side, if that puts it in perspective for you. Okay, that's what we need in order to be able to use this. If we have an angle in the 2 adjacent sides, the area of the triangle is equal to, well, this is going to be pretty similar here now, 1/2 the side length A times the side length B times the sine of C. Sine of C. All right, and let's label this here. Okay, so let's say that I've got a triangle, and it's important to note here it does not need to be a right triangle. Okay, so we're starting to apply our trig to non-right triangles. This does not have to be a right triangle. Let's look at an example here, though. Let's say that I've got any arbitrary triangle. Let's call it this one. And let's say that I call this A, B, and C. When we name sides, we name the corresponding angles the capital letter across from that side. So this would be angle A. This would be angle B. And this would be capital C, angle C. So if I want to find the area of this triangle, I take 1/2 the side length A times the side length B times the side of the interior angle. Let's take a look at an example of this. Okay, so again, we can connect our letters here. I like showing where all my letters go to. Okay. The side lengths are the lowercase letters, the angles are the uppercase. Let's do one of these triangles here. Let's say I've got something like this. Nice small triangle. And let's say that this is 6 centimeters. This is 14 centimeters. And then in here, this angle is 105. So in order to find the area of this triangle, the area of the triangle will be equal to 1/2 times the two side lengths, which is 6 times 14, times the sine of 105. Well, then we just plug this whole expression into our calculator. Or we can simplify it some first. 1/2 of 6 is 3, and 3 times 14 is 21. So I can say that this is 21 times the sine of 105, which we can approximate 21 times the sine of 105. Let's see if you can come up with that on your Desmos calculator. So 20.28. What are we talking about here? Let's take a closer look at this triangle. Okay. Degrees is an excellent guess, and it's the answer I wanted you to say, but let's think about it, okay? I'm glad that we're making this mistake because look, we're finding the area of a triangle. What are my measurements given in? There you go. Square centimeters. Okay, so the area of my triangle is what we just solved for. The area of the triangle is 20.28 centimeters squared. Okay, so it's important to have labels, particularly when we're talking about area, because So we're not just talking about arbitrary lengths. These are very specific. Let's do one more example and then we'll be done today. This is it. Flying by. Here we go. Let's say that I've got this triangle. I'll make it a rather large triangle this time. We'll call it, make this one X and Y and Z. Okay, and I'm going to ask a couple questions as I set this up. Which angle do I need? Okay, so let's ask it like this. Which angle do I need? Which angle do I need? If I tell you that this is 17 inches and this is 22 inches, which angle do we need? X, Y, or Z? Good. It has to be the included angle. So I need this. Okay. So that means if I give you that this is 18 degrees, if I tell you that, what is the expression for the area of this triangle? The area of the triangle is equal to what? Let's see if we can come up with the whole thing here. You can use a decimal or a fraction. Good. So our area will be 1/2 17 times 22 times the sine of 18. Let's see if anybody got that in your Desmos calculator now. Farewell, Gruber. Farewell, Ethan. Farewell, Grace. Farewell, Taylor. Farewell, Caitlin. Bye, Tim. Bye, Megan. Bye, Alexis. Bye, Juliana. Bye, Elizabeth. Bye, Clarissa. Have a good day, Caden. Bye, Coco. Have a good day, Gavin. See you, Gavin. Bye, Trevor.